Hello guys, this is me. I'm the med guy. I'm here to assist people that do A level and AS maths and alongside other subjects that I'm interested in that I've done in the past A levels. So just a brief introduction of who I am. I am a student, med student in the Middle East, and I'm just uploading YouTube tutorials on past papers, and I hope they're educational and informational. I just hope that people that don't have resources can look through this and get better insight in onto the paper. So we start off with C1, January 2005. So you can see that there's no calculators allowed. So question number one, write down the value of 16 to the power half. So the key thing here is to realize that a half onto a power is the same thing as a root. So they're asking for the square root of 16, which you could have guessed is 4, because 4 times 4 is 16. So square rooting 16, which should give us 4. 4 squared, 4 squared, square root is 16. Okay. Next, find the value of 16 to the power of minus 3 over 2. So to understand what's going on here, we need to get rid of the minus. So whenever we have a to the power of minus, let's say 3, what we really mean is that it's the same thing, but it's 1 over that same power. So similarly, we can say this is 1 over 16 to the power 3 over 2. So now all we need to find is 16 to the power 3 over 2. Now, when you have an expression, when you have a fraction on top on the exponent, what happens is we have this following rule. So we have am over n. We take the nth root of a and we put it to the power of n, if that makes sense. Now, what's really going on here? So let's break it down even further. So we have a 1 over n, right, times m. So this is the same thing as saying a 1 over n times a to the power m, because they when we when we when we when we're timesing powers, we're also timesing by them over here as well. Sorry, I meant to say we raise them to the power of m. Yeah, same thing here. So we'll just plug in the numbers. So that will be 16 to the power half, all the way cubed. Now 16 to the power half, we know from the previous question, is 4. 4 cubed, that will be 4 times 4 times 4. That will be 4 times 4 is 16. 16 times 4 is 64. So answer to part B is 64. The answers so far are 4 and 64. All right, go to question number 2. So given that y equals 5x cubed plus 7x plus 3, find a dy by dx, b d squared y over dx squared, and part 2 asks for the integration of this expression. So, so the first thing I notice here is that the first dy over dx asking for the first differentiation. Now, the easiest way to differentiate is to bring down the power and multiply by what's left. Okay, so we have the 3, this goes down, and we take away from 1 from the power. So what we're left with is dy over dx, right, is actually 3 times 5x, and 3 minus 1 is 2, so it's squared, plus 7. Why 7? Because x is to the power 1, and if we take 1 away from the power, it becomes 0. And anything to the power 0 is 1. We don't do anything with the 3 because it does not have x, any component of x or coefficient of x, so we cannot differentiate it. So it's a constant, it's left alone. So our first answer, so part A, I can write here, is 15x squared plus 7. Now part B says d squared y over dx squared. Now what that means is we're going to differentiate part A again. Now, if we were to differentiate part A again, the only expression, the only variable that have the term that have x components are the first term, so 15x squared. So if we differentiate this, we take down the power, like we did before, take down the power, and we subtract by 1. So you're left with 30x, and that's it. So that's your answer for part A, and this is the answer for part B. So part C now. Part C or part II. Now the key thing with this is, for any integration or differentiation for the matter of fact, you try to first make the powers, make these expressions more easily readable. So instead of 1 plus 3 root x, you write 1 plus 3x to the power of half, and similarly the other one, x to the power of negative 2. Why? Because it makes it easier so when we're integrating. So II. So when we integrate this expression, 1 plus 3 x to the power of half minus 1, so not minus, minus x to the power of minus 2 dx. What are we really doing here? So it's one is very easy to integrate. It becomes, x, just the variable itself. Now the next one is, it's a bit different. It's 3x to the power of half plus 1. We add 1 to the power and we divide it by the same expression, half plus 1. Same thing again, minus x to the power of minus 2 plus 1, and we divide by minus 2 plus 1. And then obviously you also have to have plus c, or else you don't get the marks. Okay, so let's simplify this. This would be x plus, now this is what? This is 3 over 2, and this also 3 over 2. This is minus 1, and this is also minus 1. So you're left with 3 times, so we have x to the power of 3 over 2, and we're dividing by 3 over 2, so we're really timesing by its reciprocal, so 2 over 3, right? Next, now we have, how many minuses do we have? So we have a minus, time we have this negative sign times by this negative 1 over here, so we're going to be left with the positives. That will be plus x to the power of minus 1 plus c. So now let's just tidy it all up. Becomes x plus, so you can see here the 3 and the 3 here cancel, so you're left with 3 plus 2x to the power of 3 over 2 plus x to the power of minus 1 plus c. Now that's your final answer. Over here. So this is your final answer for C, and we are done with that. Okay, so plus C usually is 1 mark. So out of the 4 marks, that would be 1 mark, and the rest would be just to get these expressions, these terms. Okay. Part 3. Question 3. Given that the equation kx squared plus 12x plus k equals 0, where k is a positive constant, has equal roots, find the value of k. Now, immediately, I always see this when I'm looking at these types of questions, is that it always has equal roots. Now, what does has equal roots mean? Now, as soon as you think of has equal roots, you should always think of the discriminant. Now, why do you need to think about that? It's because it's related to the question. Now, if an equation has equal roots, it means that b squared minus 4ac, which is the discriminant, equals 0. So we can apply this to our normal ax squared plus bx plus c equals 0 quadratic equation. So what's the a here? A is k, b is 12, and c is k. So now we can use those terms to solve the equation. So what's b squared? So that's going to be 12 squared minus 4 times a, which is k, minus times c, which is also k, and this equals 0. So you're left with 12 squared, which is 144, minus 4k squared equals 0. Then we go to the other side, becomes 144 equals 4k squared, and you're left with k squared. We divide both sides by 4, so that will be 144 divided by 2, so that's going to be 72, and then you divide that by 2 again, that would be 36. So 36, k equals plus or minus square root of 36, so k should equal plus or minus 6. Now we go back to the question. What are they asking for? They're asking for the positive constant. K, the positive constant. So K can only equal 6. So that's our value of K. This is our answer here. Okay, so next we have, let's go solve the simultaneous equation. So solving the simultaneous equation. So we have two equations. One is linear, one is linear. So this is a linear equation, and it's not a linear equation, so it's exponential. So what we have to do is we have to substitute either this, we have to substitute this equation into this, and then solve. So what I usually do is I make x the subject or y the subject. Any case it works. Now for this scenario, I'll just make x the subject, so that will be x equals 2 minus y. So that's our first equation that we're going to use. So that's our first equation that we're going to use. So we're going to plug that equation into here. So that will be what? So 2 minus y squared plus 2y equals 12. So you're left with, so we have to expand the bracket. So that will be 2 minus y plus 2y equals 12. So let's expand the brackets. So first inside, inner, and then outside. So that would be 4 minus 2y plus y squared plus 2y equals 12. So now let's simplify all of this. So that will be y squared minus 2 cancels with the other plus 2y. You're left with just another minus 2y. And this becomes plus 4 equals 12. Move the 12 to the other side. Y squared minus 2y minus 8 equals 0. And then it's a matter of factorization. So now we need to think of all the possibilities. You can get minus 8 when you multiply two numbers, and when you add them, you get minus 2. Now, because I have a lot of practice with this, I can instantly know that this is y. So I always write this first, y equals 0. And then I instantly think of minus 8. So what are the factors of minus 8? So that will be minus 4, minus 2, minus 4 and 2, 2 and minus 4, minus 8 and 1. So you can list them down. Now, out of practice, I remember that what two factors add up to minus 2. So that's going to be minus 4 and plus 2. Now we can check this. So minus 4. So we can check this by minus 4 times 2 is minus 8. And then if we add the minus 4 plus 2, you get minus 2. So this is the sum. This is the product. So in that scenario, I know that it works. So we know that this equation is actually correct. So moving on. So what are the y values that we get? So y equals 4, because this expression has to equal 4. And the other one we have is y equals negative 2. Now we're not done here. You still need to find what x is. So we use the same equation that we came up with. And we use that equation. We plug it back into this. So this becomes, so x equals, so 2 minus 4 is minus 2 over here. And then x equals, so 2 minus minus 2, that'll be 2 plus 2, that is 4. Now you can write it as this is also correct, or you can write it as coordinates. I prefer coordinates, they're much more neater. You have this, but you can still use your own method. So this is the answer for question number 4. If I remember correctly, I did not have this. That's right. So that's the answer for question number 4. You can either write like this, or you can write like this. Either way is fine. It's up to you, your preference. And just as a side note, you could have also made y the subject here. Y the subject, y equals 2 minus x, and that's that would have still been fine. Like this is also correct. This is also correct. This is not wrong. This is also correct. Okay, so let's go down. Question number 5. We have the rth term of an arithmetic series is bracket 2r minus 5. So part A says, write on the first 3 terms of the series. So that's pretty easy, right? So we just substitute when n equals 1, n equals 2, and when n equals 3. So that's going to be 1. So that will be 2 times 1 minus 5, 2 times 2 minus 5, and 2 times 3 minus 5. Now, this isn't the way I would do it because I know what arithmetic series are. What I would do is I know the first term, so that's going to be 2 minus 5, which is minus 3. And I know they're going up in 2, so every term is going to be plus 2. I know that. It's an arithmetic series. We're always adding. So in my mind, I know if it says 2r, we're always going to be adding 2. So minus 3 plus 2 is minus 1. So minus 1, and then minus 1 plus 1 is 1. So I know just by looking at 2r that my first, if I know the first n equals 1, if I know the first term, I can know the other terms because of the 2r over here. Okay. Now, part B. This is what we're just coming to. Part B says, state the common difference. Now, this common difference is obviously 2 because we know that if you look at the common difference, we're always adding what? We're adding plus 2. So D, which we usually use as the common difference, is 2. And part C says, show that the sum of all terms when r equals 1 to n, bracket 2r minus 5, equals this expression. Now, in order for us to do this, we need to know the sum of n numbers, right? Now, the sum for any arithmetic series is denoted by this. So n over 2, 2a plus n minus 1 times d. So this is usually what we refer to when we talk about sum of an arithmetic series with n numbers. So with n numbers. Okay. So what we have to do is we have to plug in all the values here from 2r minus 5 into this. Now, do we know what n is? No, we're just going to keep it that way then. So we just continue. So that'll be just n over 2. Do we know what a is? Yeah, we do. A is usually the what? A is usually the first term. So this is the first term. Now, do we know the first term? Yes, we do. Why? Because the first term is minus 3. So we know this is going to be 2 times minus 3, which is minus 6, plus n minus 1 times d, which we also know is 2. So we know what we're doing here. So now all we have to do is simplify. So n over 2. So let's expand the bracket. So that will be 2n minus 2 minus 6. Then if we simplify even further, that will be n over 2. That will be 2n minus 8. Now we're almost there, but you see the half over here, and you can see that inside you can divide by 2. So what will happen, let's take the 2 out. So n over 2 times by 2, bracket. Now if we divide both 2n and minus 8 by 2, you're left with n minus 4. Then both the 2's cancel, and you're left with your final answer, n bracket n minus 4. Alright, so this is the proof question, so there isn't really a direct answer, it's just the steps that we had to go through. So the first step for this was remembering that the sum formula is this. Second step was substituting into this, so I'll just write a little sub and the formula. And the third step was just simplifying. So if I write this as simplifying. Alright. So question number 6. So figure 1 shows sketch of a curve with equation y equals f of x. The curve crosses the x-axis at points 2, 0. So that's over here. That's over here. And 4, 0. That's over here. So these are our x-coordinates, x-intercepts. You can call them as well. The minimum point of the curve is p bracket 3 minus 2. Now in separate diagrams, would sketch the curve with equation y equals minus f of x. Part B, y equals f bracket 2x. Now the key with this is to remember what these transformations mean. Now y equals minus f of x is actually a reflection in what axis? It's in the x-axis. So reflection in the x-axis. So that's first thing we need to know. Second thing we need to know for part B is what's happening to the 2x inside. Now, by rule of thumb, I always remember that whatever we do inside the bracket, we're actually doing opposite to the diagram. So if it says 2x over here, that means in the real thing, I'm stretching it by, so I'm dividing it by 2, you know? So in this case, that would be a stretch. So you divide the x coordinate by 2. So in this case, I'll divide x coordinates by 2. Alright, so now let's draw them. So I'm just going to copy this. I'm just going to maybe move it across, perhaps. No, this. Because I've copied this, and I'll move it down a little so you can see it. So this is what we're dealing with. This is the initial graph, right? This is the initial graph. So we have to draw, so this will be part A, right? So we have to draw a graph. So I can get straight line graph. Okay, now we're getting somewhere. So x and y. So because this is a reflection in the x-axis, I did not write the x-axis. Sorry, x-axis. What's happening is we're flipping this graph over here the other way around, right? On the line of this axis here. So what's gonna happen is this is going to now look something. I'm going to hope to draw this correctly. It's going to look like this. So let me try that again. Nope. Yeah. All right. So that's somewhat what it looks like. We have reflected the x-axis in the x-axis. What happens is the only thing that has changed is the y coordinates. They have flipped, right? They're flipped. So in this case, the coordinates are still the same, right? Because on what is the question asking again? The question saying give the coordinates of the points where the curve crosses the x-axis and the coordinates of the image P under the given transformation. So we always need to remember P and the x coordinates, right? So this is P, this is the coordinates. So the coordinates have not changed. They're still 2, 0, and this is still 4, 0. What has changed is the sign of the y coordinate of P. So it's still 3. Nothing has changed to the x-axis, the x coordinates. Just the y has switched to now plus 2, right? So part B, I'm going to do that again. Okay, and we're going to draw another one. Nope. Maybe another straight one. Okay. All right, so you got the y-axis, the x-axis. Now, because we're dividing the x coordinate by 2, this graph is going to look much narrower. It's going to look more narrower by a scale factor of 2. So instead of looking like this, it's going to look something like this. So I hope I've drawn it correctly. Drawn it as in, like, there's a little bit here. I can maybe I can maybe smoothen up a bit. So I can do it like this. Here you go. All right. So the x coordinates and P have now divided by 2. So instead of 2, 0, now this coordinate is now 1, 0, and this is 2, 0. And our coordinate P is actually, so 3 divided by 2, so that's 1.5, but the y has not changed. The y stays as it is, right? So you can write 1.5, or you can also write P equals 1.5. It's up to you. Both are correct. Okay? Both are correct. All right, so that was question number 6. Move on to question number 7. So, question number 7. The curve C has the equation 4x squared plus 5 minus x divided by x, where x cannot equal 0. The point P on C has x coordinate 1. Show that the value of dy over dx at P is 3. So where does this all come in? Let's see first. So first we have to do is simplify the expression first of all. So y equals 4x squared, and we can simplify this expression over here by dividing 5 by x and minus x by x. So that will be what? That will be plus 5 over x minus x over x. Now this can simplify down to y equals 4x squared, 5 plus 5x to the power minus 1 because it's divided by x. And this is just 1, isn't it? So we have got that. So show that the value of dy by dx at p is 3. So first we need to find the differentiation of this. So over here, so we have to find dy over dx. That's pretty simple. So we bring down the power and subtract by 1. So 4x squared would become 8x. And 5 minus x, 5x to the power minus 1 becomes minus 5x to the power minus 2. The one stays as it is. Okay. So now we want to show that the value of dy by dx at p is 3. So what are they really asking for us? They're asking us to substitute the x coordinate of p, which we already know is 1. So what do we have to do? We have to sub in, we have to put it in a, so I have to sub in x equals 1 into the equation. So when you sub it in the equation, becomes 8 times 1 minus 5 times 1 to the power minus 2, which is just 1. So this becomes 3. So we have proven that the value of dy over dx at p is 3, that we know that it's 3, because we substitute x equals 1. So part B says find an equation of the tangent to C at P. Now, the equation for finding the tangent is usually y minus y1, y minus y1 equals x minus x1, right? That's usually the equation to find tangents or any form of line, any lines, right, that you have coordinates for. Now, at P, we know what x is, but we don't know what y is. So we need two things. We need the x coordinate and we need the y coordinate. So in order for us to, and obviously the gradient, the gradient. So we have x, we know it's 1. We don't have y, so let's find that. So we need to sub in, sub x equals 1 into y, which we have not done. So that will be 1. So let's see what that will be. So that will be y equals 4 times 1 plus 5 times 1 to the power of minus 1 minus 1. So that'll be what? So 4 plus 5, which is 9, minus 1 is 8. So our y coordinate is 8. And our gradient is part A, because dy by dx, or the differentiation, is also called the gradient function. So this is the gradient function, isn't it? So we know the gradient at P is 3. So we can just sub in everything into this equation we have. Y minus y1 equals m bracket x minus x1. So this becomes y minus, so what's our y values? 8. Our gradient is 3, x minus 1. So then we simplify, so y minus 8 equals 3x minus 3. So y equals 3x. So minus 8 goes the other side, becomes plus 5. Then we have C. So part C says, so this tangent line that we got here, right? So this is the tangent line we got. This is the answer to part B. The tangent meets the x-axis at point K0. So find the value of K. So we're saying, when we talk about the x-axis, when we have an x-intercept, what are we saying? We're saying that y equals 0, doesn't it? So 0 equals 3x plus 5. So minus 5 equals 3x. X equals minus 5 over 3. So our value of k at this point is minus 5 over 3. So k equals minus 5 over 3. So this is a crucial step to do right at the end, minus 5 over 3. Alright, so question number 8. So we have a triangle here, the points A, we have the points A, 1, 7, B, 27, 27. We have C, coordinates PQ. They form the vertices of a triangle ABC. We can see that. And the point D, which is 8, 2, is midpoint across AC. So we know that this is midpoint. So these are the key information that we see from the question itself. The question asks us find the value of P and Q. Now we know because this is the midpoint, from getting A to B will be the same as getting D to C. So if you can see over here, what happens when you go from A to D? We go 7 across, right? So we go 7 across in the x-axis, and we go -5 in the y-axis, the operation that we need to get to D. So we apply the same thing here. So we add 7, and we take away 5 from 2. So you're left with 15 here and -3 here. -3. So let's do it again. So -3 here. So what's P? P is 15 and Q is -3. That is that. So that's the answer for part A. Part B, the line L, which passes through D and is perpendicular to AC, intersects AB at E. Now, what is that? What does all that mean? Now, what they're saying, there's this line over here, right? There's this line over here. Now we can say this line over here. It passes through D. Now, if I am correct with this, I should be able to move it around and around here. So this is perpendicular. So this is, let's cancel. Okay. I have no idea what happened. Okay, so we're back here. So the line L is perpendicular to AC, so it's perpendicular in this way. You can see that it's 90 degrees. So just visualize it. So this is 90 degrees here and 90 degrees here. So this is perpendicular to AC, and it intersects this line AB at this point here. So we're going to call this point E. So that's what we're going to call it. We're going to call this point E. All right, so we have to find that point. First, we have to find an equation for this perpendicular line. So the way we do this is first we need to find the gradient of AC, right? So how do we find that? We go to AD and then so we need to find the gradient of AD. That's going to be, so it's always delta y over delta x. So you're changing y or changing x. So we just take one point. So let's say we take A first, 7 minus 2 over 1 minus 8. So that's going to be 5 over minus 7. So that's the gradient for AD. But we want the gradient for this line L. So that would be, so gradient of line L would be -1 divided by -5 over 7. So the gradient of that would be the reciprocal, and we take out the negative. So that would be 7 over 5. Yeah, 7 over 5. Now, to find the line, we do the same thing we did before, is we use the equation y minus y1 equals mx minus x1. Now, the only coordinates we know that pass through line L is D, so that's the only coordinates that we can use. These are the only coordinates that we can use. Only coordinates, because these are the only coordinates that actually pass through the line AC and this line L. So this becomes y minus 2 equals our m, which is 7 over 5 x minus 8. Now let's look at the form they want it in. They want in the form ax plus by plus c equals 0. So the best way to do this is to multiply everything out by 5. So once you multiply everything out by 5, you get 5 bracket y minus 2 equals 7 bracket x minus 8. Simplify this. It's 5y minus 10 equals 7x minus 56. Bring the y to the other side because it's ax plus by. So this becomes 7x minus 5y minus 56 plus 10 equals 0. So your final answer over here for part B here, is 7x minus 5y minus 46 equals 0. So that's what you're left with over here. So this is our answer to part B. Part C says find the exact coordinate x coordinate of E. Now to find that, all we have to do is substitute y equals 7. Now why do we substitute y equals 7? Because if you look at this line over here, AB, the line AB, so the line AB is a straight line, right? It's a straight line of y equals 7. You can see that, right? This is a straight line of y equals 7. So all we have to do is substitute y equals 7, find the x coordinate. That will be 7x minus 5 times 7 minus 46 equals 0. 7x minus 35 minus 46 equals 0. So you're left with 7x. So minus 35 minus 46, so that's minus 76. That's minus 81. That's minus 81 over here. So 7x equals 81. So x equals 81 over 7. Now this is also correct. You can also go one step further and write x equals 11 and 47. Personally, I feel 81 over 7 is also correct. I usually just go with 81 over 7, but both are equally as correct. So this is the coordinate for this and this. That's question number 8. All right. So move down to question number 9. We're almost done. There's 10 questions in this paper. So question number 9 says the gradient of the curve C is shown by this equation. The point P1, which is the coordinate 1, 4, lies on C. Find an equation of the normal to C at P. Now, they've done half the job for us. They already found dy by dx. So all we have to do is substitute 1 into this equation. So part A, so if we substitute dy by dx, when you substitute 1, you will get, so 3 times 1 minus 1 squared will be 2 squared, which is 4. And that's the gradient of, that is the gradient, it's not the normal gradient, is it? So this is the gradient of P, which is 4, but we want the gradient of the normal. So that's going to be, so always remember the perpendicular gradient is always, so this usually refers to perpendicular, by the way, perpendicular. That's just something I picked up. I've seen a lot of people do it. It's very easy to remember. So perpendicular usually equals -1. That's the key thing that we're supposed to know about perpendicular lines, right? So the gradient of the line times the gradient of the perpendicular line should equal -1, or else it's wrong, right? So that's the key concept here. So 4 times that perpendicular gradient equals -1. So the perpendicular gradient is -1 over 4, right? Now, the same thing we've done with all the other questions regarding lines. To find the equations of anything, we use this key concept: y minus y1 equals mx bracket x1. And we already have what points P are. It's 1 and 4. So we just substitute. So this becomes y minus y1, which is 4 equals minus 1 over 4x minus 1. Now, so you can leave it as, you can do two things there. You can leave it as either this, or you can times everything by 4, so that'll be easier. So 4y minus 16 equals minus x minus 1. This becomes 4y minus 16 equals minus x plus 1 plus 1 plus 1. So 4y equals minus x plus 17. So either this is correct as well, so y equals 17 minus x over 4 is also correct. So there are multiple correct answers here, so you can stick with whichever one you prefer. So 17 minus x over 4 This is also correct. This is also correct. So I personally prefer going a step further. Y equals 17 over 4 minus x over 4, just because I like being consistent with y equals mx plus c usually. So I go, sometimes I go a step further and I do this. Sometimes they ask for this, sometimes they don't. So it's all regarding the question. So part B. So question says, find an equation for the curve C in the form y equals f of x. Now, what does that mean? So we have dy by dx. They're asking for y equals f of x. So this is integration, right? Now, we don't exactly know how to integrate this. So this squared, this 3x minus 1 whole squared. So what we can do is expand the brackets. If we expand the brackets, so this becomes 9x squared minus 6x plus 1. Now, where did I get that? I got that from 3x minus 1, 3x minus 1. Now, I multiplied inside, outside, inner and outer layer. So that's where I got this from. That's 9x squared minus 6 plus 1. So we now have to integrate that, right? So if we have to integrate that, that becomes 9x squared, right, minus 6x plus 1 dx, right? So how do we integrate this? Same thing before. We increase the power by 1 and divide by the same power. So 9x. So the key thing here is 3. 2 plus 1 is 3 and divide by 3. That's the key step here. Same thing with minus 6x. So minus 6x. So the power usually is what? 1. So we have to increase by 1, becomes 2. Divided by 2. And then the last one is pretty easy. Any constant just becomes the variable, which is x, right? Also plus c. Don't ever forget the plus c. So in this case, we have what? We're left with 9 over 3, which is 3x cubed minus 3x squared plus x plus c. So we're almost there. So why is this? We're almost there. Now, the key step here is we need to get rid of this c. And the only way we can do that if we have a coordinate, which we do, right? So this coordinate, this c can be removed by this p over here, 1 and 4. So all we have to do is substitute 1 and 4 into this equation. Let me go down a bit. So let's substitute 1 and 4. If we substitute 1 and 4, this becomes, so the y is 4, the x is 1, so 3 times this. I'm just going to change the color so it's much more obvious. What are we doing? This is 1, this is 1, this is 1, this is squared, this is cubed, and let me just remove this and make it blue as well. Here you go. All right, so in this case, so we know that 4 equals, so 3 minus 3 is 0. So this is 1 plus c. So c is 3. So our final equation, y, is 3x cubed minus 3x squared plus x plus 3. That's our final equation over here. That's our final equation, and that's our final answer. All right, so next, part C. So using dy by dx equals 3x minus 1 whole squared, show that there is no point on C at which the tangent is parallel to the line y equals 1 minus 2x. So let's see. What is this question asking? Like, once we see this question, the only thing I can think of is parallel, and we're talking about gradient. So the only thing I know about parallel is we need to know parallel means you have same gradient. As far as I remember, same gradient equals parallel, right? So the easiest one to find out is the line y equals minus 1, 2x, right? So part C over here, right? So the line y equals 1 minus 2x has a gradient of minus 2. Now, the curve C, the gradient of the tangent can never be 0, or it can never be negative. Why? Because you can see that the dy over dx, right? The function itself, right? 3x minus 1 whole squared. Any number you put in here, right? Any number you put in here, it'll always be more than 0 because it's squared. So let's say you got minus 1 over 3 here. Let's say this expression is 0. This is the lowest it can be. it can't go any lower than this because the answer is squared. So let's say even if you have a negative number, so let's say you have -1 here, -1 squared is still positive, isn't it? So the gradient of this has to be always greater than 0. So by that logic, the gradient can never be -2. So the curve gradient can never be -2 ever. So by that logic, we know that there is no point on C which intersects or is parallel with the tangent is parallel to y equals 1 minus 2x. All right, that makes sense. All right, so number 10. Given that f of x equals x squared minus 6x plus 18, x is greater than 0, express f of x in the form x minus a squared plus b. So this concept over here is completing the square. Now, what I always recommend anyone, even myself, I used to do this, like disregard, disregard, disregard the plus 18 for now. All we care about is right now, we care about this expression, x squared minus 6x. Now, just by remembering it, if you have x squared plus bx, right? Completing the square form is x plus b over 2 whole squared minus b over 2 whole squared. And that's how I remember it. You can have something else, but this is usually how I remember it. So we do the same thing here. So this is x squared minus 6x. So we just substitute in. So that would be x. So minus 6 over 2 is minus 3 whole squared. And that would be minus. So 6 over 2 is 3 minus 3 squared. And then we just add the plus 18 at the end. The 18 at the end comes along. So this simplifies too. So f of x is x minus 3 whole squared. So minus 9 plus 18 is plus 9. So that's our final answer for A. The key step here was that we divided by 2, we followed the formula, and that's what we got. All right, part B. Sketch the graph C showing the coordinates of P and Q. Now, they're telling you that it meets the y-axis at P and has a minimum of point Q. Okay, so this is pretty simple now because we already know what the y-intercept is y, because the y-axis at P, this P is directly related to the 18, isn't it? So our y-intercept is 18. So that's what we know. The minimum point, because we have a completely the square form, the minimum point is usually minus PQ of, so not minus A, I'll change it. It'll be, in this case, it'll be minus AB. So in this case, that'll be what? That will be 3 and 9. So that's the minimum point. So if I was to draw this, right? So if I was to draw this, that would be, if I was to draw this. Oh, not a straight line. So let's draw this. This will be U-shaped, right? Because it's a square graph, right? So if I was to draw this, I'm going to draw it. I'm gonna hopefully try to draw this as parabolic as possible. The first part is parabolic. The second part, not so much. But you get the gist. So the minimum point here would be 3 and 9. So that will be our point Q. And our y-intercept would be x is 0, y is 18. So that's our point P. So these are our 2 points that we get on that we have. So that's the 4 marks. So 1 mark for P, Q, 1 mark for the shape, and 1 mark for the vertex being in the same quadrant. So all of the shape being in the positive quadrant. Part C, just to end it off then. So the line 41 meets C at point R. Find the x-coordinate of R, giving a point in answer P, Q plus Q, or 2, where P and Q are integers. The key thing is the line y equals 41. So that just means it's x. So it's basically it's f of x equals 41, right? Now there are two ways of doing this. Either you equate the first expression, which is x squared minus 6x. So this is either x squared minus 6x plus 18 equals 41. Or the easier route, which is x minus 3 whole squared plus 9 equals 41. Now, the problem is you can't really use the second method because, no, actually you can. Yeah, sorry, so what I was saying. Actually you can, yeah. So this will become x minus 3 squared equals, so 41 minus 9. So if I remember, 41 minus 9 is, take away 1, take away 10, that would be 32. 41 minus 32, yeah, 32. Then you square root it, so we get x minus 3 plus or minus square root of 32. Square root of 32 is what, basically? What is square root of 32? Square root of 32 is basically what? Square root of 16 times square root of 2. So that's what? 4 root 2. So x minus 3 equals plus or minus 4 root 2. So x equals 3 plus or minus 4 root 2, right? Now we want what? We want the positive one, right? Because they're telling you that finally, because x is greater than 0, isn't it? So our answer must be x equals 3 plus 4 root 2. Now, let me explain why this is easier than the second one, the first method. So this is the first method, and the second method. This is the first method. Let me just make it clear why. I prefer the second method. Because there's a square here, it's easier to square root things than use the quadratic formula. So this one we would have used the quadratic formula, which I don't like using. I prefer the calculator, or I prefer completing the square. And I prefer completing the square. So I hope you found this informative, and I'll see you next time in the next paper.